Assalamu alaikum. Good evening. Welcome all. Water chemistry class day 14. I'm waiting for you all and happy to connect you. It's near about 10:30. When you join, you please share with your tag and your colleagues on your groups. You can go for watch party and you can tag your friends and family. So I'm just waiting for you. Once you have connected, I will start when you have connected, I will start topics. So today's topic is critical ion. Yesterday we discussed cycle of concentration, and after cycle of concentration, today's discussion is critical ion. What are the critical ion can be for any water system, water treatment, water plant design, and today we will discuss what are the critical ion, how I can identify critical ion, and based on that I can design my system and other parameters. So I'm waiting for you guys to connect, and by the time I am preparing all the things and sharing in my wall. So if you join, please share. Thank you. Thank you very much. Thank you for joining. Please share on your friends and your colleagues so that they also can enjoy the same. I am waiting for some more people to connect, and by the time I like to start a song. Let's see, I keep a song for you all so that we can enjoy the song, and we can wait for people. Thank you. Enjoy the song.
We shall overcome, we shall overcome, we shall overcome someday. Oh, deep in my heart, I do believe we shall overcome someday. We shall overcome, we shall overcome, we shall overcome someday. Oh, deep in my heart, I do believe we shall overcome someday. We walk hand in hand, we walk hand in hand, we walk hand in hand someday. Oh, deep in my heart, I do believe we shall overcome someday. We walk hand in hand, we walk hand in hand, we walk hand in hand someday. Oh, deep in my heart, I do believe we shall overcome someday. We shall live in peace, we shall live in peace, we shall live in peace someday. Oh, deep in my heart, I do believe we shall overcome someday. We shall live in peace, we shall live in peace, we shall live in peace someday. Oh, deep in my heart, I do believe we shall overcome someday.
Those already connected, please share and you connect and call your friends and family to connect to understand. It's very
We are
interesting.
not afraid, we are not afraid,
We are not afraid today.
Oh, deep in my heart, I do believe we shall overcome someday. We are not afraid, we are not afraid, we are not afraid today. overcome. We shall overcome someday. Oh, deep in my heart, I do believe we shall overcome someday. We shall overcome someday. We shall overcome someday.
Thank you very much. Thank you for connecting. So we enjoy a very nice song in the Corona period. This is very important for us to be strong, to be aligned, to be united, to be positive, and should not be afraid. So thank you, Shaun, for joining. Thank you, Nazmul Hussain Bhai. Thank you joining. Whoever joined, please share on your wall and share on your team. So as today is a 14th class, and we have started class on the very first day, on day 1, and we started from basic water chemistry. Yesterday we discussed cycle of concentration, how it calculated and how it used for any cooling water system, and why it is important. So today we will calculate, we will understand what is a critical ion for any cooling water or any water system, and how we can select the ion, and what are the consideration we have to do, and why it is important, and after the selection how we can go proceed. So hope everybody doing fine. By the time, if you have any question, any comment, anything you like to ask me or you like to share me, then you can put on it. So I like you all, please share on it, and if you want to comment, please comment on water chemistry live group. I can only see your comments on water chemistry live group. If you watching from other group, please you share and come back on water chemistry group, so that I can see your comments and I can reply your question accordingly. So thank you very much. So today's topic is critical ion for water treatment. So what are the critical ion and why we call it critical ion? In water system, we know there are many ions exist, or many ion in the water. It can be hardness ion, it can be chloride, silica, iron, it can be sodium, potassium, calcium, magnesium. There are so many ions always, all the time water contain. So what are the ion can be critical and why they are critical for us? That is very important for us to understand for design any system or any plant or any cooling system or any pre-treatment plant or any boiler system or any plant to understand the things. So thank you Saiful Islam Bhai, thank you Nusrat for connecting, thank you Nazmul Bhai, thank you Shahadat for joining. Please share on your wall and connect all the people who you think important. So before going to critical ion, just yesterday we talked on the cycle of concentration. So what is actually cycle of concentration? Cycle of concentration is any ion of any cooling system blow down water divided by same ion of the makeup water. This is the cycle of concentration. Thank you Rashid, thank you. Please share on your wall and share on other people can see. So once we have understand cycle of concentration at importance, then we have to understand how critical ion can be important for us and how we can select the critical ion. So what are the things we have to consider to understand the critical ion, or to find out the critical ion for any water? First, we have to have the makeup water analysis report. For example, if I want to establish a plant, I want to design a utility system, or I want to design, or I want to purchase a boiler system or a cooling system, or I want to purchase a generator. The site I have selected, the primary work is I have to get the sample of their makeup water or their available water source, and I have to analyze the makeup water, and I need this report, and I need the correct makeup water analysis report. Second, that we have to understand, like if we consider like chiller, I'm purchasing a chiller, or I'm purchasing a generator, or I'm purchasing a process cooling tower or a heat exchanger. I have to understand the allowable range for all the parameters that should need to control in the system, that need to control in the cooling tower, that need to control in the chiller, that need to control in the boiler, so many things. So I have to understand the allowable range. Usually this allowable range come from the manufacturer of the machine, it can come from the water treatment expert, it can come from the consultant, whatever the other things, different sources. available, I have to have the allowable range for all the parameters. For example, if I have McCapator analysis and it has pH, alkalinity, conductivity, total hardness, alkalinity, many other parameters I should have. Similarly, I should have the allowable range of all of the parameters so that I can design. So once I have the allowable range and I have the McCapator analysis report, then I can calculate the cycle of concentration. Thank you, Golam Kibriya, for connecting. Please do share, and if you have any question, you can ask me. So we have to calculate the cycle of concentration for each ion. Then the critical ion we have to select, and mostly the critical ion prone to scaling, and that is a critical, that's why it's called critical. So when critical ion selected, then we have to take care of the critical ion. So what we have to do to select the critical ion? This is the chart. This is very important. So once I have the McCapator analysis, once I have the cooling water allowable limit, I am considering a cooling water here to measure the cycle of concentration or to understand the critical ion. So once I have the McCapator analysis report, and once I have the OEM limit, so what are the limit given by the OEM, once I have, then I have to calculate all the cycle of concentration of individual every ion. Like for conductivity and for pH, TDS, all these are the result for McCapator. This is the table shown. Conductivity 350, pH 6.7, TDS 200, total hardness 120, calcium hardness 75, magnesium hardness 45, chloride 20, silica 50, alkalinity 50, iron 0.3. So these are my McCapator result, McCapator report. And for any system, considering think like it's a chiller or it's a cooling system, the OEM guidelines show the limit I have to maintain for that particular system is conductivity should be less than 2000, pH should be less than 8.5, TDS 1000, total hardness less than 450, calcium hardness less than 220, magnesium hardness less than 170, chloride less than 200, silica less than 150, alkalinity less than 20, and iron less than 2. So these are the guideline we have from the OEM. That means machine manufacturer give us the guideline. So now as an expert, as a water chemistry expert, I have to calculate the cycle of concentration, mean ratio of all the parameter except pH. So if I do calculate, then I found for conductivity the ratio is 5, the TDS the ratio is 4, total hardness ratio is 3.75, just this divided by this. Calcium hardness 3.73, magnesium hardness 3.77, silica 10, chloride 10, silica 3, alkalinity 4, iron 6.67. So I get all the cycle of concentration from this list, and critical ion is the minimum cycle of concentration, the ion that gives minimum lowest cycle of concentration is become the critical ion for this water test. Because if we crosses this ratio for any other parameter, automatically this silica will cross the limit and this will create scaling in the system. So that's why I have to consider the highest silica is 150 and that ratio is 3. For example, if my calcium is COC is 4, silica COC is 3. If I do maintain TDS COC 4, so if I do maintain COC 4, then silica will be 200, like 50 into 4, 200. So it crosses the allowable limit and it will create a scale. So in this sense, here the critical ion is silica. So I think you understand how we can select the critical ion. So critical ion is the ion which gives minimum lowest cycle of concentration for the particular parameter, for a particular system, for a particular area McCapator or particular site condition. So once we have understand the critical ion, then we can understand the design, what are the things I have to do, what kind of pretreatment plant I have to design, what are the McCapator or what are the cycle of concentration I have to consider, and based on that I can calculate the blowdown, I can calculate the McCapator. Accordingly I can design the pretreatment calculation, I can design the tank size, I can design many other things. So before going the plant design, I must do the critical ion selection for any project. So once I have calculated the critical ion, then what I can do, I can set the practical limit for the system. If you see here, sorry. So if you see the table here, the same OEM limit is cycle of concentration is this, but as we found the critical ion is 3, so our design cycle of concentration should be 3. So design cycle of concentration here is 3. So if we could design our cycle of concentration is 3, then we have to set the practical limit. Our OEM limit is less than 2000 will be okay, but practically we cannot go at that level. So what level I should maintain for my system, as the silica is my critical ion. If I can't do anything for silica as a raw water, if I can reduce the silica on raw water, especially for cooling system or the simple system, it is difficult to reduce silica because we use either softener or anything that does not reduce silica. So we have to set our parameter. So if I consider cycle of concentration is 3, so I have to multiply the makeup water parameter by 3 and I have to set the limit for the particular system. Like here my practical limit will be conductivity 350 into 3 is equal to less than 1050, and similar way TDS less than 600, total hardness less than 360, calcium hardness less than 225, then magnesium hardness less than 135, chloride less than 60. Chloride limit is 200, but we have to maintain for the particular system less than 60. Then I understand the system is running perfectly. Silica less than 150, alkalinity less than 150, iron less than 0.9. So this will be my practical limit. So this is how it is important to calculate the critical ion, and this is how we can design my practical limit, and my system should run within the practical limit, not the OEM limit. Thank you very much, Shahadat. You ask a question, how will I reduce silica? Thank you very much. Basically, if we have higher silica at the feed water, like as a 50 or above, usually only the RO system or DM plant can reduce this silica. So if it is cooling tower, usually sometimes it is difficult to install RO plant as a pre-treatment unit. So people, what they do water management properly and they try to maintain the silica below 150. But sometimes either we have to reduce this silica at the raw water, and that case we can use RO plant, we can use DM plant. And that's why yesterday or someday before, Asif, our expert Asif, asked that is there any specific resin for reducing the silica? Asif Iqbal, thank you very much. We are just talking about you. Thank you for connecting. Please share with your team. I didn't see your team is here. So once we have this practical limit, we can understand the cycle of concentration. So based on the cycle of concentration, we can do some more simulation for water chemistry. What are the simulation? We can do prediction. We can do prediction for that cycle of concentration. We can predict, because we understand what will be our calcium hardness, what will be our pH. This will be my practical limit. So on that practical limit, how my water behave? My water behave as a corrosive water. My water behave as a scaling water. So we have to predict. We have to predict RSI, LSI. So what is LSI? Langley Stability Index. So we have to predict our LSI number. So later maybe tomorrow class we will discuss how we can calculate LSI and RSI in detail. But just remember, when we calculate LSI, then LSI number coming, if LSI number come is equal to 0, normally never come at 0. So 0 is a very ideal situation. But if it is greater than 0, that means scaling can form. And if it is less than 0, that means corrosion can be happen. So similar, this is a very not very extensive index, but still we have another extensive index that is called Reisner Stability Index. We can calculate Reisner index, and in this index, if we have Reisner index is 6 to 7, then we say you can predict this water is okay, water is good. If the water RSI less than 6, or it below 6, as below lesser 6, the scaling chance is very high. And if it is above 7, the more it goes 7 plus in 8, 9, 10, it will be more corrosive. So depending on the COC and depending on the practical limit. Thank you, Rafiqul Islam Nipun. So thank you for connecting. So once you have the RSI prediction, then we can understand my water is how aggressive. Will it create corrosion or will it create scale? So how aggressive, based on that we can design my treatment, we can design my plant machine, we can choose my metallurgy, which metal I should select. Should I select metal for cast iron, galvanized iron, or SS or MS, or in some cases we might have to select high grade, maybe titanium, maybe different kind of heavy equipment that is very expensive material I have to select. So this is how cycle of concentration is very important. After that we have to understand the critical ion, and based on the critical ion we have to design the cycle of concentration, and we have to design the practical limit. Based upon that we can go for establish a plan. My fortunate or unfortunate is that practically in industry people are not aware much on this, and the engineers are the the utility engineers or the maintenance managers, they are actually not aware of this. So sometime or most of the cases country like Bangladesh, so people don't calculate all these things, they just set up the plant, and that's why most of the plant having problem of corrosion, problem of scaling, and they just try to manipulate or manage in different way. That's not a very professional engineering way. So this is the calculation, or this is the topic for today's discussion. And if you have any question we can discuss right now. And I want to share something else with you all, but if you have any question please ask me. Today I discuss cycle of concentration, how to calculate critical ion, and why critical ion is important, and based on critical ion we can select the cycle of concentration, and once we have select the cycle of concentration we can set the practical limit. Once we know the practical limit we can predict the water RSI, LSI, and once RSI and LSI shows the water is corrosive or scaling, so based on that we can design my equipment, machine, or water treatment, other chemistry. So that's the things that we discussed today. So thank you very much, thank you all. So if you have any question, I am waiting for your question. If you have any question please please ask me the question. If you have any question I am ready to ask, ready to reply. Thank you very much, thank you all, thank you. If you have any question please write on the comment. And I have some proposal for you, and I have some plan. I'm coming out with different things. So please, if you have any question, please raise your question on the comments. Asif, do you have any comments, any feedback? Gulam Kibriya, did you understand what we discussed today? Saiful Islam Bhai, did you understand? Did you understand, or it is helpful for you? You can give feedback on comments, or you can write if you have any question. And Shawan Islam, Nazmul Hussain Bhai, if you have any question you can ask. Okay, thank you very much. So today I'm living in Tolarbag. So many rumor is coming from Tolarbag and many other area also. So as a corona stress time, I just like to request you all, please be productive. Many of you are working at home, so think about the companies. So do something that that can help your company to sustain, and help your supervisor, help your customers. Keep communication with your customers, keep communication with your friends, family, parents, so you become alive. So don't only waste your time, or you pass very lazy time, and it will destroy our life cycle, it will destroy our discipline. So I am requesting you all, please do take care of your health, do take care of your profession, do take care of your company, do take care of your family, and do take care of your networking. Thank you, Asif. Very nice question. Can we choose M alkalinity as cycle of concentration? Basically, sometime it should not. And if you have a critical ion for M alkalinity for any system, so you have to think that system need to do pH adjustment, and you might have the critical ion alkalinity. So you design that system with pH adjustment chemicals. So that's the best choice. And you set the alkalinity as per OEM guideline or water treatment guideline, and then you go for next minimum cycle of concentration. For example, if you have minimum cycle of concentration for m alkalinity for any particular area or particular plant, maybe 2.5, so this is the lowest cycle of concentration. So should we run a plant 2.5? So we should not, because you can easily maintain alkalinity. We can maintain alkalinity by using any acid or any alkaline reducer or alkaline adjuster in the system. So we need not any plant for that. So we will go for next minimum cycle of concentration. What is the above 2.5? What is the next minimum cycle of concentration? So usually we will not consider alkalinity as a critical ion, because we can maintain or we can manage alkalinity very easily by using PSL alkalinity adjuster. Minhaj Abedin, thank you very much for connecting. Today we are discussing critical ion cycle of concentration, how to determine critical ion, how to determine practical limit, and how we can predict RSI, LSI or before in a plant, and we can design our plant, record makeup water, record treatment plant. Thank you. Minhaj Abedin, thank you very much for connecting. Please share your wall and tag your friends and family. Asif Iqbal, thank you very much for another question. COC or critical ion? COC or critical ion? We will take critical ion that is basically give the minimum cycle of concentration. So we can say for minimum cycle of concentration giving ion if alkalinity, so we can say that critical ion is alkalinity. But for designing my water chemistry, selecting my cycle of concentration, I can go some other more or better cycle of concentration that can give or save my water or save my chemical. So for critical ion, yes, alkalinity is the critical ion. But for selecting my cycle of concentration and design my other parameter, we will go next level. Minimum COC maintain huge amount of water loss and also chemical loss. Shahadat, thank you very much. Thank you. That's why we have to when we understand the minimum cycle of concentration is the critical ion. So first we have to handle the critical ion, not the all ions. Like for example, Asif asked if alkalinity is the critical ion, then we have to understand how we can handle alkalinity. We will not select the COC on the alkalinity. We go higher cycle of concentration that help us to reduce the water consumption. Thank you very much. What about the chloride? Usually we can use the chloride, but if the scaling is my main concern, chloride sometime we can go up to a certain level. We can manage the corrosion area by keeping the system clean. Like some area chloride may be very high, especially for boiler. Chloride is very harmful. If really chloride is high, it will reduce the OS alkalinity, it will reduce the pH. So it's better to, for good plant, for sustainability, if chloride come limiting ions, we have to go for some different kind of treatment. Can be DM is the better one. If we can use DM plant, then chloride will reduce, so that water will helpful for the boiler. But if it is for cooling system, then chloride can create corrosion only. So if plant does not have much more SS metallurgy, then we can keep the system clean using dispersant or other chemistry. So if system clean, chloride can't corrosion much. Chloride will corrode very high if suspended particle is deposited. Under deposit condition, chloride is very, very aggressive. Thank you very much. Thank you, Asif, for seeking so many questions. I appreciate you. I appreciate. If you have any question, you can seek and can ask also. So I like your question. I am waiting for your question always, because question always give us opportunity and privilege to discuss and learn many things. So Minhaj Abedin, if you have any question, you can ask also. I'm sure you are hearing, right, Minhaj? Hope everything fine for Minhaj Abedin. You are doing fine. Okay. Thank you very much. So today I like to announce some of the things that will be very exciting and very good for you all, especially from my team or any team or all over the globe. This water chemistry live is, I like to welcome you all to have the live class. Yes, you can make the live call from your part if you like to share anything, or if you like to talk on certain topic, if you are thinking I can discuss. So I like welcome you all like Asif, if you agree, we can make a live call for any day. Please let me know. We can call an other expert also. I request Hasib also. I request some other my colleagues or other team who are expert in different line and water chemistry. So some people some days before ask for chiller system. So chiller system, so if you ask if you can work for chiller, how chiller works. So if you can take any class on this, or you have any choose, I don't like to choose, you can choose any topic. As if you can manage take a class, or anyone if you like to share anything regarding in our scope, so I am allowing you, you can also make a live call. The second thing is that you might already notice that we are going to prepare water TV. It's online channel. So it's already I prepare the design, logo, website, everything is working. So we are going to make a water TV. On that TV is educational purpose. We will use online different kind of class and different material will be there. So I like you all, please watch on that, join that group water TV, and you share with your different group, you invite your different people. And similarly the same goes as a YouTube channel water TV, so you subscribe on that channel and you post good quality water video on that, and whatever content, good content, if you find anywhere, you please post on that. And I appreciate your support and I need your help to make the community good. And I don't mind my competitor or other company or any other part of the globe can come here and can discuss also. I want to enhance the community who work in water, and please help me to enrich and help me increase the connection. So you please share your video on different group, you please share the YouTube channel in different group and subscribe it, and put different kind of video first on this group or in water TV group. And I think it will be very helpful for all of us to bring our network more and bring our professional enhancement. So if you have any comment on it or any question also, please do write and comments. I like to share your question. Oronno Shubro, thank you very much. You asked that sir Bangla. Yeah, basically I started this class with Bangla, but after a couple of class I found a lot of people joining from different country like India, Pakistan, Canada, different country. After that I think we should go international level. So if you have anything that you didn't understand or no Shubro, please approach me. I try to explain in Bangla. You can call me, you can WhatsApp me, you can messenger, you can inbox me, so I can explain it better. Shahadat Hossain, if alkalinity too high, yes, thank you very much Shahadat. If alkalinity too high, definitely then we have to use alkalinity reducer in any system, especially cooling system, and especially for any big system all the time is a built-in, there is a design, is a built-in alkalinity reducer application in the system. So it is always there, the alkalinity can reduce. How maintain biological growth? Very good question. There are a lot of reason biologically happen. Number one, can have to dose biocide perfectly, has to increase biocide dose, have to dose hypo or chlorine perfectly. The free chloride or hypo should maintain for at least 2 hours. So these are the few important things. Dispersion should be dosed sufficiently, correct point for sufficient time and frequency. So if we do maintain good quality dispersion, if we do maintain frequency of non-oxidizing biocide, and if we do maintain FRC for oxidizing biocide for certain day, certain time, every day perfectly, then definitely system microbiological growth should be controlled. If it is not controlled, that means any of this is not working, functioning properly. Maybe biocide dose is underdose, maybe the dispersion dose is underdose, maybe the free chlorine is not available. So either any of these three, or system contamination is very high, that means algae growth is or biological growth is very high compared to the dosing. So because of any of the region, system may be fouled by biological growth. So thank you Benjir Raymond for joining. This is a water chemistry class. We are just at the end. We started every day 10:30 p.m. and we start and we close 11 p.m. This is a water chemistry live group. So if you have interest, you can connect the first video. This is a 14th video. So you also can connect on YouTube. YouTube as a water TV. water TV channel. So you will get all the video over there, and you can watch the video and you can understand water chemistry. And Benji Rimon, thank you very much. Thank you. Have you any idea of air cooling water for cellular install? Okay, yeah, we have idea. We will discuss. If you interested to discuss anything on this, I am ready to allow you to discuss on this floor water chemistry live. So you can discuss, Benjir Bhai, also. This is an open floor for you all. So if anyone like to do any live, you just inform me earlier so that you can connect. We can connect 10:30 p.m. every day, and we can continue our learning curve high. So I think that's enough for today. Thus, finally, I would like to request you all as earlier, please sincerely work for your company, sincerely work for your personal growth, sincerely work for your customer relation, sincerely work for your networking in this period, because upcoming couple of months we will face a lot of challenges. Our business will be reduced, we will face a lot of challenges. So everybody need to be very professional to handle the challenge. So I wish all of you safe and secure days. So guys, I think no more question. Thank you very much. Thank you for connecting. Have a good day, and everybody please share it on as more as possible. Like our YouTube channel and like our Water TV channel. Take care and good night. Assalamu alaikum. Allah Hafiz.